Hi everyone, in this video we're going to look at the unit circle and we're going to introduce the idea of what the unit circle is, and ultimately our goal here is to use the angles that are drawn on the unit circle to define trigonometric ratios, that is, the primary trigonometric ratios for angles that go beyond 90 degrees and angles that are also equal to 90 degrees as well. So we're going to go through a bunch of definitions here and learn how to draw angles on the unit circle and on circles. And then in the next video and in the next series in this lesson, we're going to look at how to define the trigonometric ratios of angles in terms of what we learn in this lesson. So without further ado, let's just go ahead and we'll go through some definitions that are going to be useful here. First off, the unit circle is just a circle with center at 0, 0 and radius 1. So this point here is 0, 0. That's the origin here. So we can just, I guess, scale this so that, let's just label it so this is 0. And since it has radius 1, this will be 1 unit. This distance will be 1 unit. This will be -1. And this will be -1 as well. Because recall that a circle, if a circle has a specified radius, then any point on the circle is the same distance from the center of the circle. And since here we've chosen to center the circle at 0, 0, this should be a distance of 1 unit, this should be a distance of 1 unit, this should be a distance of 1 unit, and this should be a distance of 1 unit as well. So this is the unit circle that we've just drawn here. Now we're going to look at how to draw angles on the unit circle, and the next thing that we have to define is the initial arm. So here it says the initial arm is the arm along the positive x-axis. So let's just go ahead and we'll draw that. So the arm along the positive x-axis is just a line that's drawn along the positive x-axis, and it has endpoint 0, 0. So it has an endpoint which is the origin. Next is we've got an angle that's drawn in standard position. Now an angle in standard position, it has vertex at 0, 0 and initial arm along the positive x-axis. So let's draw this out. Well, we've already got an initial arm that's drawn along the positive x-axis. Now we just need to draw an angle such that the vertex is at 0, 0 and has this initial arm. So if I draw an angle here, the vertex is at the origin. It's at 0, 0, and its initial arm is along the positive x-axis. So technically, this angle that I've just drawn right here, let's call this angle theta. This angle theta is an angle that's drawn in standard position. The next thing that we're going to look at is the terminal arm. This arm that rotates from the initial arm is called the terminal arm. So it's this arm that I drew right here. This is angle theta, and this is the terminal arm, and this is the initial arm. Next is a positive angle. So a positive angle, if I rotate from the terminal arm, from the initial arm, and I rotate the terminal arm, if I rotate it counterclockwise, then this angle is positive. But if I were to rotate it the other way, like let's say I were to draw an angle and I were to rotate the terminal arm this way, well, this would be a negative angle, okay? So this would be a negative angle. So let's call this something else. Let's call this alpha. And alpha is a negative angle. I'm just going to erase that just because we're good to have one angle. So actually, let's write that alpha is a negative angle, and a positive angle would be theta. We also have what's called a reference angle. Now, what a reference angle is it's an acute angle between the terminal arm and the x-axis. So here, what I've actually drawn, theta and the theta is actually a reference angle because it's the angle that's between the terminal arm and the x-axis. Okay, and if I were to draw an angle going this way, a positive angle going this way, that would also be a reference angle. Now, where this gets a little bit more interesting is if we have, and where students tend to make mistakes, is if we have a terminal arm. Let me just erase some of this here, just to make things a little bit simpler. So let's suppose that we have now an angle that is drawn like this. Let's suppose now that we have an angle that's drawn like this. Let's call this angle theta. Well, the reference angle would be the angle that's drawn between the terminal arm and the x-axis. So it's actually this angle. And just notation-wise, we're going to call this angle phi in this course. So we'll call this angle phi. Okay, so that is the reference angle. And that is the angle that's drawn from the terminal arm to the x-axis. It's either drawn down to the x-axis or up from the x-axis, depending on which quadrant the angle is in. We also have angles that are called coterminal angles. So you can imagine that if I took the terminal arm and I rotated it another 360 degrees in comparison to where it is in right now, the terminal arm would end up in exactly the same spot. Now, the two angles are not the same, but they have a terminal arm that is located in the same spot on the unit circle. So we call those angles coterminal angles. So coterminal angles are just two or more angles in standard position that have a common terminal arm, or the same terminal arm. Next, we have something called a principal angle, and a principal angle, all that it is just an angle that's between 0 and 360 degrees. So let's suppose you had an angle that was like 10 degrees, or you had two coterminal angles. So let's say you had 10 degrees and 370 degrees. These two angles are coterminal angles. And let me draw this out on the unit circle. So if we were to draw a 10-degree angle, it would look something that was like this. This angle would be 10 degrees. If we rotated this terminal arm another 360 degrees, it would get back to the same spot. So 10 degrees and 370 degrees actually have the same terminal arm. Okay, the principal angle between these two coterminal angles is the angle that is 10 degrees.